Welcome everybody to the session SUSE Linux Enterprise from A to Z. My name is Matthias Eckermann. I'm Director of Product Management for Linux platforms at SUSE. Talking about A, we are discussing the architectures. And again, here we see the A to Z because we actually support 4 architectures in SUSE Linux Enterprise: the AMD Intel, the ARM, the Power, and the Z, also technically called S390X. On all these architectures, we have a common code base. This means that we use the same sources across all architectures and across all delivery formats. We call this ubiquity. We have the same thing everywhere in the same form, with the same usability, with the same tools, with the same binaries and the same binary formats. This means we do this on physical on-prem. We do this in virtual environments, on clouds, in containers, or on the Windows subsystem for Linux, which also is kind of a container. The benefit of this is that we deliver the right architecture for each specific application that you want to use, that you want to run. We give you freedom of choice with respect to the architecture, with respect to the deployment format, with respect to the environment where you run our operating system and your application. You have flexibility. In addition, it means reduced training efforts because an identical administrator experience is available across all the instances of SUSE Linux Enterprise. Now you may be curious how we achieve these common code base, how we handle this. And this leads us to the next character, the B. About building and maintaining, SUSE has put all their knowledge, all the experience of 28 years of being SUSE into a technology called Open Build Service. It is a free and open source offering. It is available to everybody to download, but also to run as a service. And this Open Build Service helps you to build from sources directly and outputs all the formats that you need or that we want to deliver to you to service and support you, such as packages, containers, ISO images, VM images, cloud images. This Open Build Service works across all architectures. But even better, it is not only available for OpenSUSE and SUSE Linux Enterprise, but it is available for many Linux distributions that you may also have heard of. The Open Build Service stores all the assets, such as sources, binaries, and signing keys for you. And it also supports a technology or an approach called reproducible builds. This means that from a specific binary, if you have the sources and if you know the build environment that the Open Build Service provides you, you can prove that a specific tool or binary that you have has been built in the environment that we or someone else claims. Not only does this give you and everybody else full visibility into how SUSE builds and also maintains our software, not only does this enable the community of OpenSUSE and other communities to build and maintain their distributions, but it also enables and enforces process. We could say a little bit that the Open Build Service is a toolified production process because it has all the tracing, the tracking, it also has submission rules and submission processes built in. So you can imagine that SUSE builds other processes on top of this, and also some of our certifications are built upon the processes which are toolified within the Open Build Service. We want to show this to everybody, and we are encouraging you to look at this, to have full trust into what we do on top of what the open source communities deliver to the world. I was talking about certifications just a minute ago. There are several types of certifications, such as cryptography certifications. A typical example here is FIPS 140-2, or the announced successor of this, FIPS 140-3. There are certifications which provide you with a proof of security compliance, such as common criteria, roughly speaking. There are certifications which certify hardening tools or say that we are following specific hardening standards, such as the STIG of the US DISA, such as CIS. There are industry standards such as IPv6, which is provided by a testing called USGV6. And last but not least, there is also what we call a safety certification, which specifically is of interest in the automotive industry and other industries, and where SUSE just started to look into, as you may have heard and read. This security, certifications and compliance is important because it gives you a certain trust, a certain validation of what we do internally and what we are developing and building, that we do all the maintenance and the service to you with security in mind. That security is not only a specific point in time, but that security really is a process which needs to be reviewed and needs to be redone every day with every build. And so security is an integral part of the whole life cycle of an operating system. It is relevant during development and deployment. It is relevant and it becomes relevant via patching, redeployment, or even rebuilding containers. Certifications show that the processes and the security measurements have been done right, and that are processes in place to redo these things in the right way also in the future. Certifications and these compliance aspects are one way of looking at development. A little bit different and sometimes even contradicting, nevertheless also extremely important, is what we call DevOps. The joint approach of development and operations, which helps you as a customer and a partner to get quicker solutions and resolutions of your challenges in your business. SUSE has, over the years, developed a number of tools, a number of deliverables and products which help you in a DevOps environment. I don't want to read out everything here, but we should highlight things like the Open Build service that we just have mentioned. SUSE Manager helps you to manage things in operations and even before. We need to talk about the integration with containers, Docker, runc, whatever you know and whatever you prefer as a container runtime. We have test and release integrations such as OpenQA, which I will talk about later, or the integration with Jenkins as a well-known tool in the open source. And certainly also comes into play that there are infrastructure software pieces that SUSE delivers and supports for you, such as SUSE Enterprise Storage, the SUSE application delivery frameworks, the Kubernetes integration, the salt management that we have, which helps you with deployment. One other area that SUSE has currently started and where we are talking about is edge computing. SUSE has looked at as edge computing already for some years. You may have heard about SUSE delivering images for the Raspberry Pi very early on in 64-bit mode. This was our first attempt to what we today call edge computing. We will continue on this path. And we have the technology to build a SUSE Edge OS, that's what we are currently researching, to help you solving the challenges of edge computing. Edge computing means that you are not developing and calculating everything in your data center. You are also not going to the cloud, but you are bringing the compute capacity that you need to manage the huge amount of data closer to where the data occur. So on the IoT devices, on the endpoints. The edge is in between the cloud or the data center and the endpoints, which is IoT. We have a deep experience to achieve critical certifications for Linux, as I said before. This is needed on the edge because the edge has unattended systems, so that it is needed that you have a secure and certified system. On the other hand, we all know that the openness of Linux helps to attract software developers on the one side, and on the other hand also helps speeding up the development that is needed to win on the edge. For SUSE's approach to edge on the operating system side, which is or will be based on SUSE Linux Enterprise, there are multiple aspects that we have in mind, such as real-time, a small footprint, a focus on performance, a stability, a long-term supportability, the capability to help you to build your applications, and also certifications and security. We discussed this before. From edge, like E, let's go to the F, like file systems. This is more a base local technology, but is nevertheless interesting because, as someone said, gold is, data is the customer's gold. And data is located on file systems. So you need to make the right choice of the file system where you store your gold. You want the freedom of choice to choose the right file system according to performance, capabilities, scalability, reliability. You may want things like checksums, like snapshot rollback, or you have a huge amount of data where a lot of duplications are in, and you want to have the file system supporting you with deduplication. This is what Btrfs offers, the preferred file system of SUSE for the operating system. But as said, we offer you the choice for your specific application to choose the right file system for the applications. Talking about reliability, another important aspect is that you have a reliability on the services that you are running. Reliability on services that you are running, we call high availability for these services. Our SUSE Linux Enterprise High Availability provides you integration with third-party vendors such as SAP and Oracle, in addition to certainly a huge amount of open source application and server applications that are supported. We are virtualization agnostic in the sense that we have plugins to all hypervisors that are common in the industry, that we can scale with network services such as IPv6 and IPv4 load balancing, that we help you with disaster tolerance, for example, by having data replication on the files, on the storage layer. This technology is called DRBD. The base technology alone, though, doesn't help you to achieve full high availability, because if the administrator is lost, the best technology doesn't help. So we provide user-friendly tools, a unified command line, and a graphical user interface. And this also brings you to another level of usability and availability, in addition to a geo-clustering capability that we have included in our offering. Going away from a cluster setup such as high availability, let's go to a new approach SUSE is looking into also in the context of edge. There is a theory or an approach called Immutable OS. An Immutable OS is an operating system that is predictable. It is not altered during runtime. It will consistently run what you suppose and assume it to run when it boots. An Immutable OS also is scalable. We are not talking about handling single OS instances in this case, but we are talking about configuring masses of instances. And this also means that such an OS needs to be easy to roll out, repeatedly to be rolled out, and that the outcome needs to be predictable. And it has in common with the approach that we just discussed in high availability, that it is reliability, that is reliable, that it can automatically recover from faulty updates, for example. This has benefits when we are talking about remote or small locations. For example, mobile base stations, edge devices, IoT devices, devices or systems that need to be always up to date due to security requirements, or systems that you can very hardly go to, or where it is hard for someone to even approach it because it's built in somewhere. So it needs to be self-healing to a specific degree. And what we hear from many customers is also that they are looking for operating systems that are smaller than the traditional huge Linux operating system distributions that we see in the world. So they should be small to be delivered on small or cheap devices such as the Raspberry Pi, or that are delivered on mass devices. I may come back to some of these aspects when we talk about transactional updates later. But before, though, we go from I to J, and we go a little bit outside of the world of SUSE Linux Enterprise into the world of artificial intelligence and machine learning, of GPU computing. Jupyter Notebooks are a very interesting technology, which reminded me when I first heard about this, about literate programming. That was a programming approach that was popular end of the 70s, beginning of the 80s. And it has this nice idea of having the code directly written together with the documentation of the code, or even the code extracted from the documentation of the code and then being calculated. And Jupyter Notebooks are similar to that. We provide this framework as part of the package hub, but we are also looking into this for building an AI/ML stack at SUSE, and this requires on the operating system level, SUSE Linux Enterprise, that GPUs are enabled, because those are used for calculating the calculations, the extract from the Jupyter Notebooks. In the future, we are looking to provide a ready-to-run stack. This could be SUSE Linux Enterprise natively, or it could be delivered via things such as a Windows subsystem for Linux, so that customers and data scientists may have an easy start, but also not only an easy start, but also an easy scaling to a full cluster, for example, by using SUSE Linux Enterprise HPC. And going forward, this means that people have an integrated workflow from design of the machine learning application to the deployment and running of their application. The character K brings us to a technology that SUSE and I'm personally also are very proud of, Kernel Life patching. It provides you with fixes for kernel bugs which affect security, stability, or data integrity, and it allows you to do that without rebooting your system. This means non-stop availability for systems and services. It means that you can align the work on the system level with business priorities, and not a specific patch drives your business priority in a direction that you do not want, or even breaks your business priorities, or breaks SLAs that you may have with internal and external customers. In other words, you are discussing planned downtimes instead of unplanned downtimes, which can be the planned downtime up to a year from the last reboot of your system. For the future, we are discussing with customers and partners whether it would be useful to talk about user-land life patching, so that selected binaries and selected libraries could be life patched, either open source libraries as provided by SUSE, or even proprietary applications which might be delivered by partners but are enabled for user-land life patching. This is currently discussed. We talked about upgrading and updating and downtimes, and another aspect that we deliver as part of our offerings to make your life easier and to give you the choice about when you do an update and how you do an update, how you do a reboot, is the life cycle of SUSE Linux Enterprise. It can be up to 16 years in total. It is 10 years of general support per code stream. It is up to 3 years for what we call LTSS, but beyond this, we listen to our customers and have introduced an option that is called Extreme Long-Term Service Pack Support, so that with a specific set of services that you may talk to us about, you can get reactive patches on your code stream. Also, we deliver up to 3 years long-term service pack support for every service pack. This gives you the decision about when you update, when you upgrade from one service pack to another, or when you upgrade from one version to another. It helps you to maintain the security and compliance needs in discussion with the application support that you need for your business. And now to something different, to a more architecture approach that we have taken over the last years with SUSE Linux Enterprise. In the past, and many may remember this, we had a purely monolithic operating system like SUSE Linux Enterprise 11. It was just one shot SUSE Linux Enterprise Server, one DVD, and that's it. With SUSE Linux Enterprise 12, we already went into a more modular approach, so that we had modules around SUSE Linux Enterprise Server which enriched it, containers, public cloud module for the integration with our public cloud partners. Life patching is kind of a module, high availability and geoclustering is it. With SUSE Linux Enterprise 15, we have even expanded this modular approach. We call it Modular Plus, because we have seen the need to free the delivery a little bit from the life cycle of specific packages. So what this means is that we want to describe in a better way how specific parts of the operating system are supported and serviced, what life cycle they have, and what rules apply to those. Some parts might have specific long-running capabilities. Others, nobody would seriously expect that they live forever or very long, because the technology, specifically in open source, is changing so quickly that we want you to benefit from these quickly changing development in the communities. And so the modular approach is something that we are looking into, and I think also to extend it even more in the future. But also it might be relevant to see that the modular approach on a traditional operating system reflects the development that the container world takes, so that this is the, let's say, the other side of how the problem that containers help solving is solved and brought into your environments. The character N brings us to more like a hardware technology. The persistent memory is a technology which means that you can keep the content of formerly volatile memory, RAM, over a reboot or over a sleep mode of a specific system. One of these technologies is called NVDIMM. This supports 3 types of memory access: memory addressable, it acts like a flash block device, or a flash block device plus a file system. The benefits are specifically for databases, and this is where this is used today mostly, that it helps with an instant database recovery. No flashing everything from the database to the disk and reloading it from a disk, but you directly jump into the memory, have your data there, all the data structures there, you jump into it and you run your database. And so, for example, SLES for SAP application supports this technology. We think that there might be more innovation based on this technology, and that's interesting to look at what will happen here. In summary, this delivers you the speed of memory with the persistence of storage. Certainly all of this is developed in open source, and so we go from N to O and we say open. We talk about OpenSUSE now. And we just a few months ago have discussed a proposal with the OpenSUSE community, which is called Closing the Leap Gap. It's a little bit funny in English, but nevertheless, the approach means that the proposal is to bring more closely together, first, the developer communities by focusing on OpenSUSE Leap as a development platform, not only for communities, but also for industry partners. Bringing more closely together user communities. Why aren't the communities of OpenSUSE and enterprise customers not working more closely together? And I do not think that SUSE is the only, and OpenSUSE are the only communities and companies who see this challenge. We need to bring this more closely together, because only then our customers are leveraging the capabilities of open source, and the open source communities also get the feedback that they may want to have about their work and about the approaches that are taken. And we want to bring more closely together the code bases of OpenSUSE Leap and SUSE Linux Enterprise by not only sharing the sources, this is what we have done for a long time already, but also offering to the OpenSUSE community the SUSE Linux Enterprise binaries for a future inclusion in OpenSUSE Leap. There is a 3-step approach proposed here. First, merging the code bases. This is going on. Second, creating a flavor leveraging the SLE binaries, potentially happening this autumn 2020. And then the last step next year, the proposal to build OpenSUSE Leap 15.3 with the SLE binaries included by default. This is currently being discussed with the OpenSUSE community. It's important to remember when we talk about OpenSUSE and SUSE as a company that these are two entities working very closely together, and that there is mutual collaboration, that there is code exchange, and that also SUSE employees are working as part of the OpenSUSE community. And one of the results of SUSE and OpenSUSE working together is what we call Package Hub. This provides the packages that are available in the wide area of OpenSUSE, OpenSUSE Leap. You have heard about the Open Build service as a tool where all of this is built. The Package Hub provides a snapshot of these packages to SUSE Linux Enterprise customers. So these tools are not supported from us, SUSE, as a company, but they are built and maintained by the community. SUSE as a company helps the community, listens to them, helps them to get this done. And this helps to broaden the package choices for enterprise users without blowing up the size of SUSE Linux Enterprise, because not every customer might need every tool at a specific point in time. And also it gives SUSE the ability to learn about what our customers actually want to see. Remember, I talked about Package Hub when we discussed the Jupyter Notebooks. This technology is available via the Package Hub. Going forward, we are looking into extending the idea of someone else providing packages to SUSE Linux Enterprise also to partners. And it's like an app store idea, but without payment. It is the approach and the idea to simplify installation of third-party software on SUSE Linux Enterprise with full integration into the SUSE systems management stack. This means ease of use for you as a customer, as well for open source and community packages, but also for ISV community packages that are available for SUSE Linux Enterprise. I talked about Open Build Service before. The twin of Open Build Service, you may say, is what we call OpenQA. Also, this is a fully open source tool co-developed by the OpenSUSE community and SUSE people. It is an automated test infrastructure, but it is not a test infrastructure on a package level, but interestingly, it is a testing infrastructure on a operating system level. So we can test installations, we can test dependency things, we can test whether a maintenance update fully fits into the framework that it was supposed to fit into. There is the ability to test varied code paths, various installation options. So you have jobs, you have needles that look into, is a specific thing correct? And the output, and this is funny, you may have a look at en.opensuse.org and then search for OpenQA. The output is not only log files, but it's actually screenshots of what this tool is doing in the background. And even more funny, you can download videos of the specific test path that you have initiated, and then you can see whether this test path works as you expected it. It works cross-architecture. It matches the needs of SUSE and the OpenSUSE community in full product testing and beyond. And it is also used by other communities who may have chosen to adapt it to their needs to also provide feedback to us or contribute code changes so that the tool in itself can be improved. Now, if you have all these packages that we provide, you may have the need that you have a firewall, that you have proxies in your environment, or that you are tired of downloading all these hundreds of updates per month for every single server, client, edge system, IoT system, embedded system, whatever. That's really tiring if you would have to download this for every single system. Now, you could use SUSE Manager to manage all your infrastructure, but in some cases, you need a more simple tool that just mirrors you repositories. Or you may need a tool which helps you to bring in packages and updates and PTFs delivered by us, program temporary fixes, inside to your organization where you have a network disconnected from the internet. This is where RMT helps. It allows and has functionality for fully disconnected work. It has a simple staging support, and it can be also used for reporting and simple management of your systems. In best cases, it actually is combined with SUSE Manager as the tool that then actually manages your systems. But still, for going through your firewall, for providing fully disconnected work, for scaling updates, saving bandwidth, handling a huge number of tools, RMT is a first step. It's included in SUSE Linux Enterprise Server as a tool. SUSE Linux Enterprise Server has a rich amount of capabilities. To bring this a little bit easier to administrators, we provide system roles, which we could describe as predefined installation options. Or we could say that best practices in installing a system for a specific need are made available to all customers. This helps to scale. It is also provided in a way that it is extensible online even, and it gives you as an administrator or customer the experience of kind of an imaging model for your installation, but it's not an image, but it is, as I said, a system role which gives you still flexibility in deploying what you really need, but you can start with such a best practice. When we talked about Edge OS before, when we talked about Immutable OS before, I mentioned that there is a technology called Transactional Updates. So what does this mean? Transactional Updates means that updates are automatic. It means, so for example, a Kubernetes or a Kubernetes cluster is up to date without manual intervention. Transactional update means that an update is atomic. So we need to make sure in such a situation, specifically in a disconnected or unattended way, that failures due to partial updates are eliminated and reverted, that we can recover from errors. And this also can be done by rollback to a previous release, so that you have always a safe state where you can start from. And you see here how this safe state, the well-known state, is what transactional updates makes a basis for the Immutable OS. Transparent also is an important point. Many people tell me that they don't want in specific environments see an operating system as a thing that they need to update anymore. They just want to run their workloads without thinking about the OS. So it's a little bit supporting the invisible OS without you as a customer losing the trust that the update process is reliable. And if you trust in this update process, then you may choose to have a more frequent update pace for your operating system than you had potentially in the past Unfortunately, we know that many customers are not updating very often because they are afraid of change due to past experience. With this transactional updates, also available in SUSE Linux Enterprise Server, we think that this fear may go away. The technology is suitable for data center and edge for specific application. It helps to automate better in all environments because it abstracts the tedious thing of updating from you. So that's something to think about and something to look at. Another capability of SUSE Linux Enterprise 15 is the unified installer. The unified installer provides you with one image where you can install multiple products, SUSE Linux Enterprise, but also SUSE Manager from. So from one single medium. This means that you don't have to choose and look at and research, oh, which media do I need for installing SLES or SLES for SUB plus SUSE Manager and potentially RMT, or I want to deploy a larger cluster. You get everything on one image and you can choose from that one image what you need for your specific deployment. The underlying technology and the underlying choices are based on the fact that we have the common code base that I talked about at the beginning of this presentation. That means we have integrated and integration of the different products here. SUSE Manager is truly built out of a common code base with SUSE Linux Enterprise at a specific point in time. This means not only compatibility, but identicality, basically. It gives you a good day one administrator experience, and based on the idea of a unified installer, we foresee that on the platform we go forward into the direction of a unified installer or develop the idea of a unified installer into something new in the future. By the way, whenever you have ideas that you want to share, please feel free to reach out to us and share your experience and share your ideas either with SUSE directly, or you may also contribute to the OpenSUSE community as an active contributor. I talked about the life cycle before, and I talked about the options, the choice that you as a customer or a partner have to update your systems whenever you want. The current state of SUSE Linux Enterprise gives you a broad choice even of major version upgrades within one architecture, but still you can upgrade from 11 to 15, from 12 to 15, you can upgrade within 12, and you can certainly upgrade within 15, but you also can upgrade, and I talked about closing the leap gap, you can certainly also upgrade from OpenSUSE Leap 15 to SUSE Linux Enterprise 15. All this is based on the experience that we have with deployment, with systems management, but it also is a matter of peace of mind. We know that many customers are looking at these upgrading in place because they are risk averse. And this is actually a good mentality because every change introduces risk. We know that, and we all look to avoid risk to make our life easier, to deliver business continuity. To provide to this peace of mind, if you're using SUSE Linux Enterprise 12 and 15, there is one technology I personally like very much, and that is the idea to not have only snapshot rollback for the full system, but that also this snapshot rollback technology can be used for service pack rollback. In other words, you can try an upgrade, But if it doesn't fit your needs, if you think you have done a mistake, or if you don't like something, you can really go back in place onto your old system, run your old system, work on testing the upgrade, and then redo it again. I talked about another technology also before, the Windows subsystem for Linux. Now, I do not want to talk about the Windows subsystem for Linux itself today, but I want to talk about how we provide SUSE Linux Enterprise for the Windows subsystem for Linux. Because one of the differences between other people potentially is that we do not need a Windows end system anymore for building SUSE on Windows subsystem for Linux. We use the Open Build service, and in the Open Build service we provide tools to build images, to sign images, and then provide a Windows subsystem for Linux image that can be downloaded via the Microsoft App Store, and this is available for SUSE Linux Enterprise and OpenSUSE. So we can build Windows subsystem for Linux fully automated. We use the capability of having reproducible builds for this, and we certainly are using automated QA steps afterwards. And even better, because we are doing this on a common code base, the RPM packages that are used to build the Windows subsystem for Linux and that afterwards you are installing on the Windows subsystem for Linux are identical to the native SUSE Linux Enterprise RPMs. This, from my perspective, is great to start some Linux applications quickly when you are already running Windows on your desktop. I am not. I'm running native Linux, SUSE Linux Enterprise 15 currently. And still, if you are running Windows, you may try it out, and then you may see, okay, here are applications where Linux might fit better to my needs. And then you have a very easy start to migrate to a native Linux system. You may wonder what the character Y is about. It is not yet another setup tool, what Yast originally was, but it is yet one more installer. So Yomi is a new type of installer that is currently used by the OpenSUSE Cubic approach with Cubic control, but there is also work being done to integrate this in SUSE Manager. It is a next way of thinking installation, also coming from the idea that I already discussed in the context of the Immutable OS and the transactional updates. That nowadays we see that many people want to install many systems in parallel and unattended. That they want simple access and a simple start to the configuration of their installer. This is why Yomi uses a YAML file, and it is easy to orchestrate with a single decision point. It uses salt states to deliver an idempotent state of the operating system, and it can work alone or integrated into a big solution such as a cluster. Within these unattended installations on a cluster, there can be different profiles. Even different hardware can be deployed on it. And also the dependencies between specific nodes are recognized by the system, considered, and then executed accordingly. Due to the integration with SALT as a systems management framework, it can be nicely used in DevOps integrated environment. And it is ready to scale. After Y, Z comes, and the character Z, I want to finish with zero downtime. So we go back from DevOps as a very modern approach to IT to a more classical approach of IT. However, let's consider this. Every downtime, regardless in which environment it is, which service it has, is a pain for the user of it. So zero downtime should not only be a goal for classical deployments, but zero downtime of the service should also be a goal in every environment that we provide, regardless which development approach, such as DevOps, we take, which deployment path we take, regardless if it is on-prem, virtualized, containerized, in the public cloud, or in a private cloud. So for zero downtime, you need a framework, a tool set at hand that delivers you the capabilities to build an environment that helps you to deliver zero downtime to your customers. 5 things I would like to highlight in this stack. A full system rollback for the operating system, the reliability, availability, and serviceability capabilities, short RAS, which very often depend on the hardware, high availability and geo-clustering, the live patching capability, as we discussed, that helps you to have a system running without reboot, and then SUSE Manager as the overarching tool which helps you to manage your infrastructure, to monitor your infrastructure, to have a proper life cycle management on your infrastructure and always the right status. So we deliver a complete solution which gives you peace of mind, but which also helps you to declare compliance towards management, towards external authorities. Customers have choice. You don't have to use all of this. You can use 1 or 2 in combination with other things, depending on your business needs. The integration is delivered based on the common code base that SUSE Linux Enterprise is being built upon, with the respective tools that toolify the processes that SUSE is working on. And all these tools and all the zero downtime capabilities are not singularly available, but due to the approach that we take, they are available wherever you deploy SUSE Linux Enterprise. And with that, I would like to thank you for listening to a run-through of SUSE Linux Enterprise from A to Z, and have all the best for you and your relatives. Thank you.